this is the um, you know the movable bridge inventors. And then I'm looking at this right here, straws. And I've been doing movable bridges, drawing them, and studying them and everything, and like from books, you know, magazines, computers, and everything. So Joseph Strauss is important in the movable bridge world for inventing three types of bascule bridges. Before he became a draftsman, Joseph Strauss graduated from the University of Cincinnati, the city where Strauss grew up. He worked with Ralph Majeski by helping him developing and improving bascule bridges in Chicago, Illinois. By 1903, Strauss had designed over 400 drawbridges. Before that, he left Majeski's firm after 10 years of working for Majeski. Strauss has an invention of bascule bridges. He had his firm, the Strauss Bascule Bridge Company. In 1905, his first design was an overhead Conway type of train bascule bridge in Cleveland, Ohio. And I'm gonna show you. Now this is his first bridge. It was built in 1905. The span is 150 feet long and was constructed by the Wheeling and Lake Erie Railroad in Wabash. It's a single track structure. The counterweight is carried by a pair of struts articulated to the rearward extensions of the main trusses. The tower that supports the main trunnions on the span that revolves is extension up to the top of the counterweight. A link that pinned to the top of the tower and to the counterweight and lies in the plane parallel to this plane through the main trunnions, and the pin at the end of the main truss which supports the counterweight struts. The four joints are at the corners of the parallel. When the span opens, the counterweight is held parallel to its original position and balance maintenance as this span revolves. See Movable Bridges, Volume 1, Superstructure by Hovey. See, I done looked at, did some studies on that as far as that. So I'll show you the 1908 seminar. In 1908, Strauss developed a similar design of overhead counterweight trunnion bascule bridge. A 170 double track structure constructed by the Chicago and Northern Western Railroad, which is the Kinzie Street in Chicago, Illinois. Now this is the similar bridge to the first Strauss Hill train. To the first Strauss overhead counterweight train bascule bridge. Now this the similar one. The bascule bridge structure consists of the three main parts of the fixed tower: a rotating bascule leaf and the concrete counterweight that rotates independently from the span. The span's axis of the rotation, the main trunnions, is located halfway up the tower. The main trunnions is located in the truss upper chord, extending through the tower. The truss has an inclined rear arm to support the counterweight. Parallel to this, the link beam connects the top of the counterweight to the tower. These two elements remain parallel throughout the span's rotation. By the bowl parallel, as the span raises to a full open position, the counterweight passes between the rear arms of the truss and compact arrangement that does not require a tail pit to prevent the span from opening further than 85 degrees. The rear arms of the trusses engages a wooden bumper on the tower motive power and provided by a pinion that of the tower which engages the rack on the operator's strut to raise or lower the span. It's CHABSHAES for historic bridges of the Chicago Northern Western Railroad, Kansas Street, built in America. And I didn't, looked into that too. I mean, that was interesting as well. Now, let me see something. Okay, let's go here. The other innovation of a basketball design is a vertical overhead counterweight train basketball bridge designed by Strauss. Now this is a Strauss overhead counterweight train basketball bridge. That's a vertical overhead located in San Francisco, California, right? The span has a counterweight that are connected by the links that support the posts that rest on the trains and by the bearings that mounts to the tail end of the basket of girders to the rear of the main trains on the opposite side of the main trains. From the navigation channel, the counterweight is stabilized by the links to the rigid posts that are mounted on the pivot pier. The counterweight is connected to the top and the pivot struts, extending forward from the top of each side of the counterweight, connected to the top of the post on each side of the roadway. When the span raises the counterweight, it bears down while the bridge raises to an open position. The underneath counterweight train basketball bridge, the counterweight is connected to the end of the girder span by pivot pins that is balanced and extends to the rear of the basketball girders by the main trains with hangers to balance the span similar to the train type. But the counterweight dips below when the span is open. When the span closes, in closed position, the counterweight that is suspended from the hangers is tucked under snugly. Now see, this is a Strauss underneath type basketball bridge. Now this bridge has been replaced. Now this is one that's located in Rochester, New York, the Stutson Street Bridge. So the Hill Train basketball bridge is constructed and commonly used for railroad service as well as vehicle traffic. The first Hill Train type was constructed in 1910 in Massachusetts. It's located in Bourne, Buzzards Bay, Massachusetts, by the New York, New Haven, and Hartford Railroad. The basketball span is 159 feet and 4 inches and crosses the Cape Cod Canal. You see, this is the early design, the first Strauss Hill Train basketball bridge ever built, crossing the Cape Cod Canal. Now its twin sister, it was duplicated. Now this was duplicated of another one that's located in Ashtabula, Ohio, built in 1911. So now this is the one that's built in The first one was built in 1910. The very first Strauss Hill Trunnion Basket Bridge was built. Today it's a lift bridge because it replaced it with a lift bridge in 1935. Now, the Hill Trunnion Basket Bridge early designs, the operating machinery was mounted on the basket span, light and the struts are pin fixed to the rear panel or bridge tower, like the HX New Jersey Transit Line basket bridges in Secaucus, New Jersey. This is the what I'm talking about now. That's the HX Erie Railroad Strauss Hill Trunnion Basket Bridge that was built in 1911. That's the early design and located in Secaucus, New Jersey. This and other early designs, the amount of power is used to decelerate the span. The operating towers are on each side of the bridge, like the HX basket bridge I mentioned earlier. One tower operates the span and the other operates the counterweight. When the span is open, the weight of the strut are carried by the span and the strut is halfway out into the span, a result of making it span heavy. When in the closed position, the counterweight is heavy in the lower position. The later design of the operating machinery is mounted on the bridge tower and the struts are pin fixed to the bascule truss. As the bridge raises, the strut goes into the counterweight support that makes the counterweight heavy. When lowered, the span is heavy. Now this is the later design bridge. You see, it's built in 1924 to 1925, and so it's located in Jacksonville, Florida. The span is supported by trunnions, which are fixed to the end of the span at rear panel bridge tower. The rocker link is connected or fixed between the trusses framework to the span on the bridge tower, where the operating machinery and struts are connected. The struts with racks are pin fixed to the span, and the pinions engage the racks on the operator struts to raise the basket span. The counterweight is made with a single block or tool wing that attaches to the truss framework on the basket span and on the bridge tower. When the span raises, the counterweight that's fixed to the truss framework swings down under the bridge tower to offset the basket span, and the link arm folds against the framework. The operating machinery that's mostly mounted on the bridge tower are better suited for operation. An example, the Strauss Hill Trunnion bridges, one in Ashtabula. The machinery is mounted on the basket span. See, the drive machinery is mounted on the basket span. Yep, you see. The other in Detroit, Michigan, the operating machinery is mounted on the bridge tower. Yep. You see the machinery is mounted on the Conway Bridge Tower right there. The Hill Trunnion basket bridges often single leaf but they are double leaf heel chain basketball bridges. An example, a double leaf Strauss basketball bridge is a 333-foot single track railroad bridge, formerly Canadian Pacific, now Wisconsin Central Railroad, that crosses the U.S. Ship Canal, the St. Mary's River, Sault Ste. Marie, between Ontario and Michigan. That's Strauss double leaf basketball bridge, a railroad heel chain type, located in Sault Ste. Marie, Michigan, and Ontario, Canada. This double leaf heel chain type is still in service, and a few double leaf heel chain basketball bridges in California and one formerly in Hamilton, Ontario, Canada. William Scherzer painted his first four-track rolling lift bridge in 1893 at Metropolitan West Side Railroad in Chicago. Now, this is his first four-track rolling lift bridge designed by William Donald Scherzer before he passed on, because he ain't get to see his first bridge because he died in 1895 or 1893. After his death, his brother Albert Scherzer took over the firm of the Scherzer Rolling Lift Bridge Company. Albert Scherzer designed many rolling lift bridges in many parts of the world. They are all popular around when the span rolls back and forth in open and lowered positions without the connection like other basketball bridges have. It's easy to navigate in a raised position for marine traffic. This span has a curved track called quadrants, with the hulls able to mesh with the horizontal track lug on teeth to keep the bridge from slipping while rolling back and forth, opening and lowering. The counterweight is attached to the quadrants and has a rack beams on each side of the span with the operation drive machinery and the pinions to open and close the span. The tread plates are Achilles heel to the segmental girders that connects to the basketball span, and curved thread plates, the horizontal girders, support the flat tread plates which used for the teeth with conduits on all rolling lift bridges, also while rolling back and forth during operation. The variant type is a raw type rolling lift bridge painted by Theodore Raw and designed by Ralph Majeski. Raw's paintings are held by the Strobel Steel Construction Company, and large example of a 278 double leaf raw type rolling lift bridge in Portland, Oregon. See, that's a Broadway raw type of basketball bridge. It's located in Portland, Oregon, and also was designed by Ralph Majeski. The span operates by rollers that rolls on a horizontal track girder that rolls off its track in a closed position. The counterweight is fixed to the pier with swinging struts that turn the pins on. Also, when the span is closed, the pedestal on the main girder sits on the pinion on the pier, and the rollers lifts from its track, and the strut is hinged to the main girder. The bottom rack engages the pinion similar to the Strauss Hill Training Basket Bridge on a fixed span and the abutments. Then the pinion draws the operating strut with racks causing the contact with the track and with the trunnions. Brown. Thomas Ellis Brown was better known as a mechanical engineer of bridges than the designer. In 1896, Brown turned his specialist into movable bridges. His invention of the design was a drawbridge in Brooklyn, New York, crossing the Harlem River. When Brown worked with another bridge engineer, Alfred Butler, for a short time. See Connecticut, historic highway bridges, notable bridges and builders of Connecticut, or Connecticut's historic movable bridges, Mystic River page. Brown painted a ballast beam heel train type in 1922 and was constructed by American Bridge Company fabricator. Let's see this a Mystic River Bridge painted by Thomas Ellis Brown, located in Mystic, Connecticut. The bascule span is 84 feet 8 inches between centers of the end bearings and provides the clear channel of 75 feet between the fenders. Vertically, the moving counterweight is connected to the span by wire ropes were not used. The arrangement of the method of the variant of the leverage of the articulated links, the movable span counterbalanced by two concrete counterweights. The place, excuse me, yeah, the articulated links, the moving span counterbalanced by two concrete counterweights placed on the center lines of the main girders and carried by balance beams in the form of trusses, while the rest of the trunnions at the top tower bent. These hangers. You see some real quick. The movable span balance of two concrete counterweights of the main girders of the carried by the balance beams of the form of trusses, which rest on the trunnions at the top of the tower bents. These trusses are 60 feet long overall, and the forward ends are connected with the plate girders and moving by the hangers links or suspenders, concentric bars and short links having the double settings of pivots of the span end butt blocks on the stop, suitable place on the upper flange to the movable span girders to make the contact with the short links to the proper time during motion and change the point of rotation of the bar hangers from one set of pivots to the other. So let's go down here. A new brown type built in 1924 was built by Wendell Brown, not affiliated with Thomas Ellis Brown or relation to him. Was improved by the located the articulated butt links on the channel end of the balance beams. The better details of result from the movement of the butt links to the end of the balance beam and control of the balance simple equally. The bull wheel toggle actions avoid the affected and simple method of the operating a small bridge like the Mystic Bridge mentioned earlier, but for the large and heavier structures, an operating strut and rack will be chosen. A brown type in Ashtabula County, Ohio. And I'm gonna show you something. Now this is a brown type designed by Wendell Brown. Yep, so in Ashtabula, Ohio. The unbalancing of the leaf by cantilever action of these struts near the open position can be corrected by the proper selection of the points of articulation of the butt links. So it's going to be part 2. So stay tuned.